Hi everyone, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the Project 2 video for the Raspberry Pi without the Raspberry Pi, RPI, no RPI. So you have to have watched the first video first because it's very important. It has a ton of very, very important information. And this video takes place right after the first video is made. So as you can see, we've still got Project 1 set up. But we're going to have Project 2. We're going to start Project 2 now. So the first thing we want to do is go to File, not New Project, New Python file. And just name it Project 2. And as you can see, we got Project 2 up here. We don't want to start a new project up here. We want to add to the project. So basically, this means we have all of our imported modules will already be imported. We don't need to do it again. Main.py was Project 1. This is Project 2. As you can see, it's completely empty. So let's go back to the project page. Project 2, sending and receiving data. I'm going to take the Python code. I'm going to copy it. Throw it in here, and when I'm ready to run it, I'm going to go to run, not run main, I'm going to go to run down here, and I'll select Project 2. Now it's going to fail because we don't have our RPI, no RPI connected. Now keep in mind, you're always going to have to keep in mind the COM port that's selected. So I've got COM4 being used right now. This is all talked about more in Project 1. But in this video, we're going to send and receive data. So the Raspberry Pi, the RPI, no RPI, will send something to the send data to the RPI, no RPI, and the RPI, no RPI will send data back. So first things first, let's get things loaded. I'm going to go back to the project page. I'm going to download the Arduino code. Create a new project. Get rid of this. Paste it in here. And save it as RPI Project 2. And I'm going to plug in my RPI, no RPI. As you can see, the port is empty. There's nothing connected. So I'm going to connect it. COM4. Perfect. I'm going to upload it. It's going to take a minute to compile. And I'm going to run the program afterwards, but we have set up instructions. We're just using the LCD again. We're not using anything else. So you can leave your jumpers from the last project in place. We're really never going to take those off. We don't need to take those off. In any case, we've got our LCD backlight enable on GPIO pin 11, and we've talked about most of this stuff before. We'll talk about the code a little bit after. It's all fully commented. These project videos serve more to show you the project, how to upload, and how to start and troubleshooting, and what the project does, how to set it up. The rest is basically up to you to read the comments. So what I'm going to do is I've got the code uploaded, and one second, let's try running the program. So we already have serial imported. Let's run it. Run Project 2. Stop and rerun. I'll try running it again. Run project. So what's happening right now is it's sending data and it's receiving a value back. However, it's only receiving a valid value back when we send over a value of 5. and this has to do with the Arduino code. So as you can see at the bottom of my screen, I'm getting something in the shell down here. This is feedback from the system. So let me stop the video. I'm going to show you the LCD on the Raspberry Pi or Raspberry Pi, and I'm just going to show you what's happening. Essentially, when we send a value of 5, the Arduino code, or rather the RPI code, is programmed to say, "Hey, you said you sent me a value of 5. You're talking to me," and ignore everything else. As you can see here, if you can see this going along, we're sending a value of 0, and we're not getting anything back. We're getting a value of 0 back until we send 5. So sending 4, sending 5, and then we see waving back. So we'll look at the code in just a second. Let me just show you the RPI, no RPI in action. I'm going to stop the program. Actually, I'm not going to stop the program. I'm just going to pull out my my camera. So as the programs are both running, the LCD is off. Why is that? Because it's ignoring commands from the RPI, no RPI until the RPI, no RPI sends over a value of 5. And then it says waving back. When it says waving back, it turns the backlight on, says waving back, sends a command back to the Python program to say, "Hey, I've received something." So this is basically an exercise in address. So if you have several different devices and you only want for it to respond when you've sent it, when you're talking to a specific address, this is the case. So if I was connected to a few RPI and RPIs, I could have them with different addresses and have them do different things when they're being talked to. So the RPI and RPI is doing absolutely nothing when it's being sent commands until it sends a value of 5. 5 is, if you watched the first video, which I'm sure you must have by this point, 5. The Python code sends over a value of 5. The Arduino, or the RPI and RPI, receives a value in ASCII. So 5 in decimal is 53 in ASCII. So in the Arduino code, it's looking for an incoming value of 53. And when it receives a 53, it says, "Hey, it's talking to me." So then it sends a response back to the RPI and RPI. So the RPI and RPI program, the Python program, is really just sending 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then resetting back to 0, sending 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is only responding and executing a very specific program when it's being talked to specifically. I've given it an address of, basically the instruction of responding only when it's been sent over a value of 5, a 5 decimal or 53 ASCII. So let's have a quick look at the code. So first things first, let's talk a little bit about the Python code. This should already look familiar. We got we're importing our modules. Time is for sleeping or delays. Serial is to communicate with our RPI no RPI. We got the set to COM4 115200. Now, here's another thing I'd like to talk to you before we move on with this. When the system is locked, if during try we cannot establish communications with the RPI no RPI, which is done with this specific line of code right here, then it goes to accept and runs this program, and it says system locked, cannot communicate with the MCU, close the program. Now, if this happens, you might think, okay, well, my RPI and RPI is connected. I've got COM4. I've got the matching COM number. I've verified this in my Arduino IDE and in the control panel. It is connected to COM4. The baud rate is matching with the Arduino code 115200. What else could it be? Well, it could be one of a few things. It could be the RPI no RPI isn't plugged in. It could be that the Arduino IDE is being a jerk. If this happens and you've exhausted all other options, try closing closing down Arduino IDE completely, because it might be hanging on communication. You see, if you're communicating, if the RPI no RPI is stuck hanging or talking to the Arduino IDE, then we can't establish communications with it. So your common problems are going to be a mismatched COM4 or mismatched COM line, incorrect baud rate, your RPI no RPI is plugged in, or the Arduino IDE is being a pain in the butt. So, and here's another one. If you have the Arduino IDE serial port opened, let's just open this up. If we have the serial port opened to get system feedback, that means that the RPI no RPI is established communications exclusively with the Arduino IDE. if we have a serial port open anywhere, and sometimes it's hard to even see in the background, you can see it if you hover over the Arduino IDE at the bottom. You'll see a serial port. Then you have to close that. Again, if all else fails, just close down Arduino IDE completely. Upload the code to the RPI new RPI, then close this completely, and then try running the program again. Now in the last video, I also noticed that this stop button was being finicky. Sometimes what I do is I just click it a whole bunch of times, and that will actually turn the program off. Sometimes that's finicky, so just keep clicking it until it actually goes gray. All right, so I'm just going to start running it again. Run project 2, and yep, successful. So it's going to start running stuff in the background. So try ignore this for now. The stuff at the bottom. We've seen all this. Let's go down here. This is a function called slicer, and we're going to get to that in a minute. Slicer is a great function that I put together, and I'll get to that in a minute. We've talked about our definition write read. However, we've made a modification to it from project 1. So in write read, we send over a value of x from the main code down below, and we send over information. We send it over here. We send over x to the RPI new RPI. We set up a variable called data as a global variable, which means we can talk to it inside and outside functions. And so at this point, this command says it's waiting for a response from the RPI new RPI. If nothing happens, it just returns a value of 0. This is return data. So basically, we'll get to this in a second. Let's go down to the main code. So again, I don't want to go through every piece of code here. It's going to take way too long. I've outlined everything here, but let me give you an idea of what's going on. So this is very similar to project 1. We created x, we created counter, and we run this forever loop while true. We place the value of x. We replace the value of x with the value of counter in string form. So the string value of counter. We print it to the shell down here, sending 8 in this case. Sending plus x, and x is the incremented value that we're seeing down here. Value equals call the write read. So we send over x in write read. We call this function, and the returned value, or the return data is placed in this variable called value. You could call it Jobu or whatever you want to call it. I've called it value. So in this function, we say value equals write read, the return value from write read, we send over x. So let's go back up to write read. Send over x, send x to the RPI new RPI, and make global data a global variable. Data equals any response from the RPI new RPI. Return data. So the returned value from the RPI new RPI is returned in value. Value. So then we print the returned value plus the string version of value. I don't actually think you need to add str here, but just do it anyway. I think that the return the data in value is already in string form, but it's not going to hurt anything anyway. So then we want to do something else. We want to say value. We want to call another function called slicer. So we're going to send over in slicer. We're going to send over information, the string version of value. And again, I don't think that value is. I think value is already a string. It's not necessary, but it's good practice. So we're going to call this function, and then it's going to slice up whatever's in here, and it's going to return it here. So whatever we got from above from our write read function, the returned data from the Arduino IDE, we are going to slice it up. So let's look at the slicer function. We're sending over the returned value from the Arduino IDE, or from the RPI new RPI. And this explains what's going on here, but when we receive a value back from RPI new RPI, it looks something like this: B5. So what we're gonna do is we're going to slice it up. We're going to take stuff out of it. We want to turn this back into an integer, like a number, but it's a string. It's characters. So what we need to do is use the replace function. value equals value, but replace anything with any b's, replace any b's with nothing. And it explains what we're going to see, what it should look like after. Then we're going to do the same thing, but only we're going to replace any colon with nothing. So then after that, we should be left with an actual number. However, that number is still a string. It's still a character. It's not a number. So now we're going to say value is an integer version of itself. So now we're changing it from a string back into an integer, and we're going to return value. We're going to return that. And that's where this is. Again, this is all commented. Maybe the comments will do a better job explaining it than I am. But now that we've sliced it, we're going to print our new number after the function, and we're going to print the string value of it just so we can print it, because you can't print just a when you're concatenating two things, you want to have this in string form. So we're not changing it back, but we're printing the string version of value just for this. So if now that we've gotten the value back from now that I think about it, I probably shouldn't have named it value. We should have named this variable something else to make it less confusing. But if the data in here, the integer data in here, the number is 5, print the Raspberry Pi RPI no RPI just waved back. Then increment counter equals counter plus 1, and if counter equals 10, reset it back to 0, just like in project 1, because we're sending over the back at the top of the loop. We're sending over the value in counter. We're changing x into the string version of counter. So every time we're basically looping this. Counter increments, we're sending from 0 through 9, and we're only getting a value of 5 back when we send over a value of 5. And then there's a bunch of information down here. So hopefully that's not too convoluted. You know, if you're very new to Python, some of this might be kind of hard to grasp. But read the comments. I've tried to be very careful with how I've commented this, and sometimes I'm on the spot here trying to explain it as I go. Let's go back to the Arduino program. Okay, so we've talked about this before in project 1. We're creating a new variable called hold, and we're setting up the LCD, setting up the backlight enable, turning the backlight on, printing project 2 briefly, waiting 2 seconds, setting up our serial port for communications at the baud rate of 115200. As I go along with these, I'm going to repeat this stuff less and less, but anyway, then we're going to turn the backlight off after 2 seconds. This is the main loop. Wait for a communication from the RPI no RPI. Once we have a communication, place that value into incoming byte, clear the LCD, print this to the first line of the LCD, print the actual incoming byte value, keeping in mind that the LCD is off only when keeping in mind that the LCD backlight is off. If incoming byte is 53, which is 5 and decimal, which is place a value of 5 and hold. Otherwise, place a value of 0 and hold. So only when we get a value of 53, which is 5 in ASCII, which is 5 decimal 53 ASCII, we're going to place a value of 5 and hold. Then we're going to call the waveback function. Waveback function is down here. Clear the LCD. Serial print hold. So now we're sending back data. So if it wasn't talking to us, if it sent any other value other than 5 or 53 ASCII, this hold will hold the value of 0. Otherwise, it'll hold the value of 5. If hold equals 5, turn the LCD backlight on. Print waving back on the LCD. Wait 2 seconds, clear the LCD. Turn the backlight back off. Otherwise, like if it was 5, do this. Otherwise, else, wait 1 second and clear the LCD. So very simple code. All it's doing is waving back and sending back a value of 5 as an acknowledgement that, hey, you've spoken to me, you've sent me a value of decimal 5, 53 ASCII, and I'm waving back. All right, I hope this makes sense. Again, as the projects go along, we talk about some of the same concepts over and over a bit, because there's a lot of the same code, and new variables added every single time, new elements, new little functions. So thanks for watching. Stay tuned for Project 3.